All right, guys. So today we're going to do composite arguments and linear combination properties. So what we pretty much are going to do, guys, is we're going to take a linear combination of cosine and sine. So what I mean by linear combination is literally just two waves that have the same period, same frequency, and they create one unique wave. And you can write, because they create that one unique wave, we can write it in terms of one cosine with a phase displacement. That's what's neat about it. So example, when I say linear combination, check this out: -8 cosine theta plus 3 sine theta, linear combination, and there it is. That's it. Just cosine theta and sine theta, and notice that the periods are both 2 pi, and I just have a coefficient in the front, and that's it. And that's the only time, well, maybe not necessarily the only time, but this creates a one unique wave that can be represented with a cosine. It could also be done with a sine as well, because cosine and sine are out of phase by 90 degrees, right? So you could also do a 90, replace it with a sine degrees. It would just take a little bit more calculation on your part. You just have to make everything out of phase by 90. But you can turn this linear combination of cosine and sine into one single cosine with a phase displacement relatively easy. And I wanted to show you guys real quick. I'm going to go ahead and show you Desmos here. So I'm just going to type a random equation, guys. 3 cosine x plus 5, let's put a smaller number, 2 sine y, or no, not y, x. So there it is. As you can see, I have a single wave here with same patterns, no bumps, no hills, well, I guess you can call this a hills, but I don't have any other, like this pattern repeats itself over and over. And I can write this as a single cosine. And what I mean by I don't have any other like little hills or whatever. So look what happens when I start messing with the period here. So I'm going to put a 2x there. As you can see now, I can no longer represent this as a single cosine. And, if I put a 4, if I put a 5, you can see I got more little, and this, you can kind of already see, you can still see the pattern of the cosine, but now this sine is affecting all this, right? And it's not just the sine one. I can also do the same thing with the cosine here, as you can see. So you gotta have the same period for it to be a nice cosine wave. Well, so you can have a nice wave that you can display with a single cosine. So hopefully that made sense right there to you guys. All right, so let me show you how we're going to do this, guys. All right, guys, so here we go. So let's go ahead and get right into it, guys. So let's go ahead and do an example 1. It says, let's see if we can transform y equals -8 cosine theta plus 3 sine theta as a single cosine with a phase displacement. So we're going to take this linear combination, and we're going to create one single cosine, and with a shift, with, moving left or right. So what you do is you take that -8 in front of the cosine, and that's going to affect your x coordinate. So I'm going to draw an xy grid, and I'm going to call that a horizontal displacement. So that's -8. And then that 3 is in front of the sine, so I'm going to call this a vertical displacement. Of course, it doesn't really look like that, right? It's just a wave that's going back and forth. And if this were to be physics and this were to be a vector and another vector, then we would do tail to head, connect them, and that will be called the resultant vector here. I'm going to take away the arrows because we really can't call it that. Oh, major fail. I just deleted everything. So yeah. So -8 is this much, 3 is this, and this is what I'm talking about. So how do we represent our single cosine with a phase displacement? Well, this right here, the hypotenuse of this triangle is going to be the amplitude of that single cosine. And this angle, capital D that we're putting there, and why am I writing capital D? Because that's what we have, capital D up there. And that capital D is going to be my phase displacement of this single cosine. And in a little bit, we'll test it to see if it really worked out. So here we go, guys. Amplitude equals the square root of -8 squared plus 3 squared. And yeah, I get it. You can just take away the negative and the 8, -8 there. So that's 64 plus 9, that's 73. So keep it a square root of 73. And then to find the angle D here, I'm just going to do arc tan. And if you wanted to just put positive values, 3/8, that would give you the reference angle. That would give you this guy. And then you can just subtract it from 180. I'm going to go ahead and put a negative. And that's going to give me an answer in quadrant 4. That's going to give me this angle. And all I'm going to do is just add 180 to get my exact angle for D here. So let's see what that is. I'm going to type that into Desmos. So here's Desmos. And I'm just going to go, and I'm in degree mode, so I should probably put degree here. So arctan, and I already forgot the numbers. What was it? 3 over 8? 3 divided by -8. And there it is. Oh, I said degree mode, and I'm still in radians. So mode, degree, and there I am. And I'm just going to put plus. So I guess the number is -20.556. So maybe I should do that really quick. -20.556 degrees. But we're not in quadrant 4. That's also the reference angle there, guys. Take away the negative, 20.556. We're not in quadrant 4. We want to be in quadrant 2. So add 180 to that. So when I add 180, I'm just going to push plus 180. Oops, I didn't need to put an equal sign. It was already given it to me. 159.444. So let's do that really quick. So angle D is 159.444. So what we're saying here is that -8 cosine theta plus 3 sine theta is equivalent to the square root of 73 cosine theta minus 159.444 degrees. And we're going to find out if that's true. -8 cosine plus 3 sine. So let's go and let's see what's up. -8 cosine. -8 cosine theta, or x, plus 3 sine. And I have a wave. You can't see it. You're like, Chavez, where's the wave? Let me show it to you guys. Let's see, square root of 73. So I'm going to go -12 to 12. I just want to see a little bit above, a little bit below. And then I'm going to go -360 to 360. And there you go. There it is. So now let's see. And I really should be putting y equals in front of this to keep good habits here. So I would like if Desmos were to do that. So here we go. Y equals. And I'm going to type the new function that I got, which I believe was square root of 73. And then I move, and then I type in cosine. And then I'm going to put x minus, and you can already see it has the same. And I forgot the number, so let me check. 159.444. So I'm going to write 1. Oh, no. X minus 159.444. Yay, check it out, guys. The purple line is right on top of the green line. Now let me erase the purple line by pushing this button. So look, there it is. And now look, it's going to overlay it immediately. See, it's the same. So I hope you guys enjoyed that. And the same thing's going to happen to the others, guys. So let's go right back into it. So here's some formulas. If you want to use up those formulas, that's fine. Linear combination of cosine and sine with equal periods. The periods must be the same for this to work. And yeah, let's go right ahead. You don't need to use these letters exactly, guys. I would probably stick with A for amplitude. But you don't have to use capital D. You can use any other letter. All right, here we go. We're doing the same thing, guys. 4 is in front of the cosine, so that's going to be my horizontal displacement. 3 is in front of the sine, vertical displacement. This is just so we can find our deal here. For 3, here's my angle. I'm going to call that D. There's my amplitude. It's a 3, 4, 5 triangle. In case you don't see it, just do 4 squared plus 3 squared, guys. And then to find this angle, I'm just going to go arctan of 3 over 4. Let's see what that is. I'm going to go ahead and, excuse me, arctan and 3 over 4. And there it is, 36.8699. So that's what I'm going to write. 36.8699. And so I'm going to write my equation here. So 4 cosine theta plus 3 sine theta is equivalent to 5 cosine theta minus 36.8699. If I didn't do any errors, those are going to be equivalent. And they are. We checked it earlier today, guys. Well, I did it earlier. I did this in class, and now I'm just redoing it because I didn't like my notes initially. So here we go with this one, guys. Same deal. Negative 15 is in front of the cosine, so I'm going to draw a horizontal displacement. And then 8 is in front of the sine, so I'm going to do a vertical displacement. So I'm going to say this is negative 15 here. And I'm going to call this 8. It doesn't have to be perfect. And then I'm going to connect it. So this is my amplitude for my cosine with a single phase displacement. And this is the angle D. So if you don't recognize it, it is a Pythagorean triplet. I believe it's 17. But if you don't recognize it, no big deal. Just go negative 15 squared plus 8 squared. And then take the square root of that, and you're going to get a perfect 17. And then from there, if you want this angle here, you're just going to go, you can either do arctan of 8 over 15, and that's going to give you the reference angle here, or just put 8 divided by negative 15, and whatever answer you get, add 180 to it. Because you're going to get an answer in quadrant 4, and I don't want this answer, I want that one. So when you add 180, you'll get that specific number. So let's do that real quick. So I'm going to go to Desmos again. And I'm just going to type in, I already have arctan there, so I'm just going to go 8 over negative 15. And there it is, negative 28.0. Let me make sure I got everything correct. Yeah, that's my answer there. Negative 28.072, and I'm going to add 180 to it. So plus 180. And there it is, 151.92928. 151.928. 151.928 degrees. So, negative 15 cosine theta plus 8 sine theta is nothing more than 17 cosine theta minus 151.928 degrees. And we'll see. We'll go ahead and graph this one, guys, just to make sure. So here we go. What did I have? Negative 15 there. And 8 here. And let's see. Change that to 17. And I already forgot the number. You can already see they're really close, right? 151.928. 150. That sucked. 151. 151. Everything's wrong here. 151.928. And the reason why you're not seeing the graph is because the purple one is on top of the green one. So there it is. And as soon as I push this one, it's on top of it. Yay! Another successful one, guys. All right. I hope you guys enjoyed it. Hook it up with a thumbs up. Well, if you want to give it a thumbs up, hook it up. Hopefully it made sense to you guys. And that's it. We're done.